Hi, my name is Alex, and this is my presentation for the Digital Sampling Lab. The objective of this lab was to understand digital data acquisition of time-varying signals, and we used ADACT to perform this analysis. In week 2, we were able to identify waveforms of 11 different tracks based off of their power spectrum and time history graphs, and we explored a bunch of other relationships involved in data acquisition. In week 3, we developed our own experiment to further explore and analyze frequencies in the real world, which involved data collection and then reaching conclusions from that. For me, I wanted to find if there were dominant frequencies in popular songs. The lab setup for week 2 is shown in the picture on the right. The materials I used were a DAC, and audio breakout adapter, jumper wires, a screwdriver, LabJack software, and the GTAE Signal DAC software. The data collected for this were the peak frequency and power of each waveform type, and then the discrete points, frequency resolution, and highest frequency of certain tracks, the frequency of peaks of certain tracks, the noise type and signal to noise ratio of certain tracks, as well as the filter cutoff frequency of the last track. And the procedure was to download all of the files from the Git book, connect the DAC to the breakout adapter and the software, and then initialize the settings in the simple DAC according to the Git book, ensure continuous is on to play each waveform file, and then finally record the observations and answer all of the questions in the lab notebook. Here are the results from week 2, where we identified the different waveforms of the tracks that were given to us. Noticeably, tracks 7 and 8 had white noise, and track 11 is an example of frequency modulation. In week 2, we also looked at a bunch of different relationships. So we found that frequency is the inverse of period, and that as you increase the volume, you increase the power, and vice versa. Also, that a longer record length means that you have a increased frequency resolution, and a higher sampling rate allows you to see higher frequencies. We also looked at aliasing and noted that you must use the Nyquist equation to find the optimal frequency to sample at, which is 2 times your highest frequency. And then we also looked at noise. So white noise is indicated with a flat power spectrum, while pink noise scales as the inverse of frequency, and only white noise was present in the 2 tracks that we looked at that had noise in them. And we also looked at filters, which are used to reduce a signal. For my experiment, I wanted to know if there was a specific frequency that is common amongst popular songs. And so my question was, what are the most dominant frequencies used in hit songs? So the goal of the experiment was to compare the power spectrum of the 5 most streamed songs to see if there is a common dominating frequency, and then also visualize and understand the frequency trends in these 5 songs. The lab setup for week 3 was similar to week 2, with the same materials, except this time the data collected was a time history and power spectrum for 5 frequency tones with the audio breakout and the microphone, so 10 total, and then also the time history and power spectrum for the 5 song choruses that I used in my experiment. And then the procedure for the microphone was similar to week 2, where I had to set up the DAC and the audio adapter, and then I used a tone generator online to play a specific frequency, and then I recorded that both um, with the audio breakout adapter and a microphone, with the sampling rate at 25,000 samples per second and record length to 1,000 samples. And then I did this for both the microphone and the audio adapter. And then for the experiment procedure, I just used the microphone, and I set that up as stated in the Git book. And then I used the microphone to record the power spectrum data for the chorus of the 5 most streamed songs, and I saved those files for data analysis. Here are the results for the microphone validation. As you can see, their frequencies are very similar, and so that's how we can tell that it's working. Here are my results from the experiments. Here I overlaid all of the song power spectrum so that we can compare them more easily. The table shows the peak frequency and the power of that peak frequency, as well as a general frequency range of the songs. And so common notes are that there was no common frequency. However, the common frequency range was around 300 to 3,500 hertz, and humans can hear in between 20 to 20,000 hertz. Both songs by The Weeknd had the same dominating frequency, and the power of each song varies. However, similar genres have similar powers. Main conclusions taken from this experiment were that while there wasn't a single common dominating frequency across all of the 5 songs, there was a range of frequencies that definitely dominated um, the songs, and then also popular songs tend to prefer lower frequencies. And I would need to do more experimentation to actually validate this for a broader range of songs and different genres. But in the 5 songs that I analyzed, this tended to be true. And for error analysis, the excess background noise from the microphone really didn't have a noticeable impact on the data. Here are my lab notebook pages.